Hello, I'm sitting here next to our PLC trainer experimentation board and our PLC trainings applications board. Both of them are modules of our UniTrain system. Now we will have a look of what they include and what we can do with them. Both are connected to our UniTrain interface board, which is connected to the power supply. This power will be forwarded to every connected board. Here we have a power of 24 volts. This means that the trainees can use these boards safely and the boards won't be harmed by any mistakes of the trainees. Let's have a look at the PLC trainer experimentation board. This board includes 8 digital input pins and 8 digital output pins. Each of the pins have a status LED to show the status of the input or output. Furthermore, the input pins have a switch or a button to simulate the inputs. Besides the digital pins, we have 8 analog input pins, from which 4 pins have a range of 0 to 10 volts and 4 pins have a range of 4 to 20 milliamperes. Also, there are 4 analog output pins, 2 of them with a range of 0 to 10 volts and 2 of them with a range of 4 to 20 milliamperes. Besides these output pins, 2 pins are connected directly to a potentiometer. With this potentiometer, we can input a range directly. One potentiometer simulating the voltage range and one the current range. Next to these pins, the board contains 3 LAN ports, which are connected to a switch, and also 2 sub-D ports, one with 9 pins and one with 25 pins. These sub-D ports contain additional digital and analog input and output pins with different addresses than the before mentioned. This board is designed to work in combination with our PLC trainings applications board and with our LabSoft courses. The LabSoft courses are built up by firstly explaining the background of PLCs and giving an introduction, and after every chapter there will be a test with questions for the trainees. After the introduction there are chapters explaining the logical links such as AND gates or OR gates. Also there are chapters for memory blocks such as flip-flops. Further chapters deal with analog values, 7-segment displays or state machines. To our board, this board is divided into 4 areas. The first area shows the logical links. Here we have the AND gates, OR gates and negations. Beside them, we see here an SR flip-flop or an RS flip-flop. Next, we have an area with a digital 7-segment display. This display can be connected via sub-D port with the PLC and can be driven by it. The third section is the analog section. Here we have 2 sensors, a temperature sensor and a light sensor. And also we have 2 actuators, one of which is a lamp and one is an electrical driven motor. The last section contains a cross section. Here we can simulate a traffic light, a state machine, for which we can let cars pass on the main street and have an intersection with a side street. Next, I will show you some small experiments. These experiments can be programmed in the integrated development tool codices. And here we have the three programming languages: ladder diagram, function block diagram, and structured text. First, I will show you the logical links. At first, I will show you the AND gate. Therefore, I'm connecting the digital input pin to the AND. And then I'm connecting the AND output gate to an LED. And as you can see, if I turn on both inputs of the gate, the lamp H1 will turn on. We also have negation gates. If I connect the output of the AND gate to the NOT gate and forward it to the LED, it will stay off when both inputs are on, but as soon as I switch one off, the lamp will turn on. At last, there are two flip-flops. I can connect the digital pin to the set button and one digital pin to the reset button, and forward the output to our before used LED. If I now turn on the set output, as you can see, the LED starts to turn on and it stays on. The status of the LED is saved in the flip-flop, and it will just turn off if I turn the reset button on. Right. Next, I'm going to show you the function of the 7-segment display. Therefore, we have to connect the 7-segment display to our PLC. Next, I'm loading a program on the PLC. This program simply links the status of the buttons to the digital addresses of the sub-D connector and forwards it to the 7-segment display. You can change the numbers by turning the switches on or off. This works over the sub-D connector, but you can also connect the digital pins directly to the here seen digital input ports of the display. And there are two further inputs, the LE1 and LE2. These are used to only address one display. If I turn on this switch and other switches, now I can change the number on the second display only. That much to the 7-segment display. Now we come to the sensors. Here I'm going to use the light sensor in combination with the electrical motor. As you can see, the light sensor forwards a signal to the motor, and if I lower the light input, the motor will start changing its speed and eventually stop. You can, of course, steer the motor directly over the potentiometers. Here we have an input of 0 to 10 volt and steer it directly. A third possibility, of course, would be steering the motor over the PLC. You can use any of the output pins, write your own program, and steer the speed of the motor over this. At last, I'm going to load a program on the traffic light. Here we have a state machine. Now we have to connect the PLC again with the experimentation board. And after switching it on, you can see that the main street has a green light, while the side street and the pedestrians have a red traffic light. And now by pushing the traffic light switch, the main street turns red, the pedestrians are allowed to go, and the main street turns back to green. Same works with the S3 switch, which simulates a car coming from the side street. If there's a car, the main street will stop, the side street will go, and then it will go back to green for the main street. So in summary, the students learn how to apply the basics of PLC programming. This includes logical blocks such as AND or OR gates. It includes flip-flops, and it includes timers and counters. Furthermore, they learn how to use digital 7-segment displays. They learn how to use analog sensors. They learn how to use digital inputs and outputs, and they learn how to construct state machines.